Hello, academic staff around the world. Welcome back to Caltex Academy SMU. My name is Julius, and thank you for visiting this great channel today. On our board, we have grade 11 quadrant trig identities, and in this video, we shall explore two identities. The first identity, I have discussed it in video number 1, so I strongly advise you to check also on video number 1 and learn something from there. And we're adding 1, so I will also walk you through 3 good examples in the video. So with all this said, let's get started. Now we have here a unit circle. So when we talk about unit circle, we mean the distance from the center or up to any part of this circumference is 1. So a fixed distance from the center is the same as the radius. So the distance from here up to this point is 1. If this is our acute angle theta to the horizontal x-axis and y-axis, then we'll resolve this point to both horizontal direction and this vertical direction. So this is just like moving from this point there. Maybe we can trace it also in that vertical axis using our dotted line again. Now, if this is our point, we trace it to this direction. The distance from this point up to here is the same as the distance from here up to there. And what we know is when we resolve this along the x-axis, it is cos. So it's like 1 times cos, and cos times 1 is the same thing as cos. So you normally ignore the 1 here. Now, when we resolve the same point here along this axis, sine of our angle theta. So here, the same thing, sine theta. So what we had here is what I've just transferred here. Now let's ignore this one and we can go ahead to consider the other side here. Now since this one is a right angle triangle, then we can go ahead and use Pythagoras theorem to create an expression which is our identity here. Therefore, from Pythagoras theorem, this is the hypotenuse and always represent it by r squared is equivalent to x squared plus y squared. We can make substitution. Our r, according to this rectangle triangle, is 1 and squared equals to x. Our x from here after this side is cos, and we also square this cos theta squared plus from here up to there, that is the opposite to this one, and according to Pythagoras theorem, this is the height and sine theta. We also need to square. Therefore, squaring 1, we get 1 equals squaring cos theta, we get cos square theta. And from here, we move on to the next step. We have the square of this sine is also sine square theta. And that is the identity. But in most cases, we write it starting with sine. So when you have sine plus cos is the same as cos plus sine. We can write it here and we have sine square theta plus cos square theta always equals 1. And that is the grade 11 identity we're talking about here. We're going to use in our video. So maybe let me call this 1. And for 2, since we discussed it in video number 1, I'm just quoting it here, and feel free to check on that video to also see how it is derived. Therefore, tan of any angle theta is the same as sine theta over cos theta. So when you get tan squared, then you also have here sine square theta and cos square theta. Depending on what power the tan is raised, always sine and cosine will raise to the same power. So these are the two trig identities we will be using for our question. Now with all this said, let's move on and take a look at our question number 1. So for our question number 1 is here saying simplify tan square theta times cos square theta. Now when you have these kind of questions like that, the only thing we have to do is to copy our identities near here in order for you to see which one works for a particular question. Let's move on and do that quickly. We're given tan square theta and we multiply this by cos square theta, and this is equivalent to, since we have tan square theta, we're going to replace this by sin square theta over cos square theta. Let's move on and have it here as sin square theta over cos square theta, and this is the first part here. Now we multiply this by the next one here, and that is cos square theta. So it can cancel with this. So when you cross this one out, then what you're left with only is sine square theta, and that is the simplified version of this question. So that is the main aim of the question, is to simplify, to make something look simpler. Now we're done with question number 1. Let's move on to question number 2. Yeah, for question number 2, this says simplify 1 over cos square theta minus tan square theta. And before we start answering question number 2, if you have not subscribed to the channel, do well to subscribe to the channel, like this video, and share with friends. So if you have done that, thank you, and let's continue with the video. Now in this question, we have 1 over cos square theta minus tan square theta. For now, what we can do is to write this in terms of sine and cosine. We just recopy the first step here, and that is 1 over cos square theta minus, instead of writing tan square theta, we're changing it as sine square theta over cos square theta. Now from here, since the denominators are the same, then you can subtract the numerators, maintaining one denominator. Therefore, we'll have here 1 minus sine square theta over a common denominator, cos square theta. But when you look at this from our first trig identities, which was sine square theta plus cos square theta equals 1, we can write this identity in terms of 1 minus sine square theta, meaning we can make cos theta the subject here, and we have cos square theta equals to 1 minus sine square theta. And this is exactly the same as what we have here. Therefore, we can replace the numerator by cos square theta. So when you have cos square theta over the denominator, the same cos square theta, then this divides to 1. And therefore, that is the simplified version of question number 2. It's just straightforward, and I think we have all gotten it well. So let's move on to question number 3, and that is the last question for this video. Okay, from question number 3, it says prove that 1 minus sine beta over cos beta equals cos beta over 1 plus sine beta. If we are asked to prove an identity, what we can do is to select one side of our interest, and the general rule of thumb is to look at the side that looks a little bit complicated, and you work out to get some expression similar to the other term which looks somehow simpler. But when you look at this expression or this equation, you realize that in terms of its complexity, the left-hand side is the same as the right-hand side. So you feel free to take any of the side to prove. So for now, I'm going to walk you through on how to prove using each of these sides, starting with the left-hand side, then move to the right-hand side. But of course, if you are asked in exam, you select one and you work out using what you've selected and what best suits you. Now let's move on and start working. So this time we're considering the left-hand side. So from the left-hand side, it is 1 minus sine beta. So this is divided by, okay, let's say equals, so cos beta. The next thing we can do here is to rationalize the numerator, and to rationalize the numerator we need to multiply by the conjugate of the numerator. So conjugate is just only reversing the sign here. If the sign is positive, we reverse to negative. For now, we have negative. We can reverse it to positive. So let's go ahead and do that. So in a bracket, because we multiply, we have our original expression 1 minus sine of beta. Now this will multiply the next expression, which is the conjugate of our first expression here. And since it was negative, we place a positive, also sine of beta. For this expression to be equivalent, then we have to also multiply the denominator by the same expression. Okay, for now, the denominator we have cos of beta, and this multiplies also 1 plus sine beta. Now, when you look at this expression, from here, we are beginning to making something looking exactly like the right hand side. Remember, we said this is left hand side is what we are working with, and this is our right hand side. So we are ensuring that in our working from left hand side, we'll obtain something similar like the right hand side. So from here, you can see already 1 plus sine beta is appearing here, and we have result to 9. Now let us go ahead and expand this. There are many ways of expanding. If you recognize this one here, from difference of two squares, then you can see that the first one here will be squared, and we have 1 square minus the next one here is sine. Also, beta is to be squared. Now let's do that, and we divide this by the denominator, and let's maintain the denominator the same. We have our cos of beta, and this is multiplied by, maybe we need to maintain this same color here, and we have 1 as sine beta. So this one closes up, and we will simplify what we have in the numerator. Therefore, 1 square is 1 minus sine square. We can bring it in or square before the angle, and that is how we normally write. So, placing this over the same expression cos beta times 1 plus sine beta. Therefore, when you look at this expression again from our first identity, we have just derived up there. This is the same as cos square beta. So replacing the numerator with cos square beta, then we can get something like this. Cos square beta all over our cos beta times 1 plus sine beta. Therefore, we can see also that this square will have to cross with the denominator, and we are left with only 1 cos beta from the numerator. Therefore, we can write the remaining terms here. Cos beta is over 1 plus sine beta, and that is exactly equals to the right hand side. So we can check our expression up here to make sure that it's the same. And indeed, when you look at here, it's cos beta over 1 plus sine beta. So this is for somebody who has considered the left hand side and worked through to make sure that we get something that looks like the right hand side. What if we consider the right hand side, since the chances are 50-50? Let me walk you through that. So we can say O cos beta over 1 plus sine beta, and this is right hand side. What we can do is to also rationalize this, and we get the conjugate of the denominator here. From the numerator, we have cos beta, and this multiplies. The conjugate from the denominator is 1 minus sine beta, and we can close that up. Then we divide this by 1 plus sine of beta, and we multiply by also 1 minus sine beta. Now we can maintain the numerator like that because something is looking exactly like the left hand side there. And coming to the denominator, as we copy the denominator the same, cos beta into 1 minus sine beta, and we close it up. This is again difference of two squares. If you don't know how to work with difference of two squares, you go ahead and expand slowly. Use distributive law where you multiply the first term with the first term here, then the first term with the second term. You also move here. This term is that, and this term is that, and we come up with an expression that looks like 1 minus sine square beta. So from there, since this one exactly looks like what we have here, but the only difference here is this is with square, then we can write in terms of cosine because we have this cosine here. Since the expression from the left hand side don't have cosine from the numerator, we need to get rid of this cos beta by writing this from our identity, which was sine square beta. For now, the angle is changed, plus cos square beta. So therefore, cos square beta is the same as 1 minus sine square beta. Now replacing this denominator by only cos, we have the numerator still the same. Cos beta times 1 minus sine beta, and the denominator has reduced down to cos square beta. So from here, we need to cross this cos beta with one of the cos beta here, and left with also cos beta. So let's forget the remaining things, and that is 1 minus sine beta is divided by cos beta, and that is exactly equals to the left hand side. Maybe you can go ahead and prove to see that it is exactly the same thing. So this is our left hand side, 1 minus sine beta over cos beta, and that is what we have just gotten down there. If you have watched up to this time, if you have not subscribed to the channel, do well to subscribe to the channel, share this video with friends, and see you in the next video. Peace out.